Hey everybody, in this next video lesson, I'm going to talk about a concept of surface tension and how it's affected by intermolecular forces. Now, what is surface tension? Well, surface tension is a layer of cohesiveness at the surface of a liquid. Have you ever done a belly flop into a pool and you've hit your body, your back or your stomach flat against the water, and it's almost like you're hitting a solid surface even though the water is liquid? Well, what you are experiencing is the surface tension of water. You see, on the outside edge of water, the water molecules are attracting to each other, and they're attracting left, right, and everything underneath. But there's nothing above to kind of counteract the attractiveness that the water molecules feel under the surface. If you look into the middle of the water droplet, this water droplet is being attracted or attracting to all the molecules on the outside of it. And so that attractive force just kind of gets spread out evenly among all the molecules. But on the surface, the attraction is only to the things to the left, right, and underneath it. And what happens is it creates this skin or this cohesive surface that almost feels like when you hit it flat against your palm of your hand or your body, or maybe you throw like a board on top of water and it makes a really loud thunking sound. That's because it is interacting with the surface tension. And so the higher the intermolecular forces means that there's a stronger attraction to the other molecules, and as you'd probably expect, the surface tension is stronger. Let's take a look at a data table down below where I have various substances and a measure of their surface tension. Now, surface tension is measured in newtons per meter, specifically millinewtons per meter. You don't need to know that. It's just a numerical value. But the numerical value will help us explain the presence of the intermolecular forces. Let's first start with water. Water is a very small molecule but has hydrogen bonding, and it has a fairly high surface tension. We call it 72. It's because it can hydrogen bond, not once, but twice. Think oxygen is in the middle and it's got two hydrogens. Each one of those hydrogens is partially positive charge and there's a partial negative charge. So each hydrogen can be a spot for a hydrogen bond with another water molecule. So it can hydrogen bond twice. Because of that, and its very small nature, it forms a very, very strong attraction to other water molecules and has hydrogen bonding, and that is the surface tension that is resulting in 72 up here. Now the next one is mercury, which is just a simple atom, but it's a simple atom, but that atom is a metal, and metals, as you remember, form attractions to other metal molecules in the form of a crystal lattice. So it's a liquid crystal, but it's still a crystal. And crystal lattices are very strong. And very strong crystal lattices are basically super strong dipole-dipole or super strong hydrogen bonding, which is why its number is so much higher than that of water. Because it's not just held together by dipole-dipole or even hydrogen bonding like water is. It's held together by crystal lattice attraction in metallic bonding. Metallic bonding is something we studied previously. The next one down is ethanol. Now, ethanol, as you can see, also exhibits hydrogen bonding, but it can only exhibit hydrogen bonding once, where water can exhibit hydrogen bonding twice. Now, ethanol is heavier than water, but because water has double the hydrogen bonding power, then ethanol doesn't create such a strong surface tension compared to water. It does have hydrogen bonding, but it does not have double the hydrogen bonding like water, and as a result has a weaker surface tension than water. Now the next one is octane, which is a large molecule, but it's non-polar, so it only has London dispersion. It's much larger than ethanol, but its surface tension is an equal strength to that of ethanol. We talked about in the last video how increasing mass results in increasing intermolecular forces, but it's non-polar, so it only exhibits dispersion forces, whereas ethanol is smaller and has stronger intermolecular forces due to its hydrogen bonding, which is why these two molecules, although vastly different in mass, have the same surface tension, because this is a smaller molecule with less mass but stronger hydrogen bonding, where this is a larger molecule with larger mass but only dispersion forces. Well, hopefully this helps explain the connection between intermolecular forces and surface tension. Thanks for watching.